Hi everyone, welcome back to our CSEC quadratic series, and we are on a topic called the perfect square. Right now, but don't foresee this video taking too long, right? The reason is it's just to introduce you all to this concept. Now, you might want to know how can we jump to this session here, and maybe we're just on graphs. What does have to do with graphs, right? We will get back to the graphs in a very short while, I promise you. Right? So there's a special type of expression in maths, and this is called a perfect square. Now, what I want all you to do is take however long, pause the video, and try to find anything in common with these five expressions here. Anything that you can think about in common, see if you can find them. All right, so pause the video for however long and think it through. Right? So now that you paused it and you thought it through, right? What do we have in common? So if we notice here, right, all of the variables here, their power is 1, x to the power of 1, p to the power of 1, m to the power of 1, w to the power of 1, y to the power of 1. And if you forgot, anytime a variable is by itself, the power is not 0, it means the power is 1, we just don't write it, right? So all of these variables, their power is 1. Similarly, their coefficient, right, a word that we would have discussed before, is also 1. Yeah, and then we have some other number. Now, I only have whole numbers here, right? You can add or subtract them, right? But it could be fractions as well. I didn't include fractions because the fractions are a little bit hard. Now, what we want to see, these are all perfect squares. This is what a perfect square is, right? Now, what we want to see is something special about a perfect square, right? So let's base this here, right? So we expand out each one of these. Now, first of all, anything squared means you multiply that something by itself. So x minus 3 squared means that you are taking x minus 3 and multiplying it by x minus 3. You all know how to do this, and if you don't, drop back a few sessions, right? At probably around 6 or 7 sessions, and you will see how to expand these brackets, and this will be the result, right? If you don't know how to do it, please check back the other sessions in this series and you will find it there, right? But we want to try and figure out something special about this here, right? So let's look at these numbers, right? So I'm gonna put this in a different color. Let's look at this number here, the middle number, and relate it to C. So we want to see if B, because remember this is ax squared plus bx plus c, if that has a relationship to C. So we're looking at 6 and we're looking at this 9 here. How are they related? If I divide 6 by 2, right, and this is the same as minus 6x plus a half of 6 is minus 3 squared, or a half of minus 6 is minus 3, and minus 3 squared is 9. Yeah, since I'm writing on the side here, a half of negative 6 is negative 3. Now let's see if it's the same thing for this one here. X squared plus, sorry, this was the p squared plus 12p plus a half of 12, a half of 12 is 6, and 6 squared is 36. So that's this number over here. So this will give us 6 squared, right? We're just rewriting it to see if we see something common here, right? Let's check this one here now. What is a half of negative 10? A half of negative 10 is negative 5. And negative 5 all squared is 25. We're starting to see a pattern here for when we expand difference of two squares, right? Minus 10m, sorry, minus 10m plus minus 5 squared. And similarly, we don't even have to check this one too much. A half of negative 16 is negative 8. And negative 8 squared is negative 8 by negative 8 is positive 64. So this is negative 8 squared. And lastly, same thing, a half of 8 is 4, and 4 squared is 16. So this could be written as, right, this was supposed to be y here. Y squared plus 8y plus a half of 8 is 4 squared. So what is a perfect square? A perfect square is any quadratic, right? So a perfect square is any quadratic, is any quadratic of the form, is any quadratic of the form x squared. Now also look at all the coefficients of the squared terms. The number in front of all of these are 1. Remember, when they're by itself, it don't mean the number missing. It just means that we left out the number is 1. So it's x squared plus bx plus whatever b is. You find a half of it or you divide it by 2 squared. And check something cool here. Look at this number in the brackets. That's this number here. And look at the number inside these brackets. -3, -3, 6, 6, -5, -5, -8, -8, 4, and 4. So once you identify that something is a perfect square, you could factorize it into x plus whatever b is, you divide it by 2 squared. So once something is a perfect square, you could factorize it into this way here. So let me show you. Let's say, for example, factorize, we want to factorize these quadratics here. All right, so factorize 1. Let's go with x squared plus um, 14x plus 49. So we know it have the long way to factorize it. Find two numbers when multiplied, give you 49, and when added, giving you 14, and so on. But if you could identify that this is a perfect square, you could do this. So let's see. X squared plus a half of 14 is 7. Yeah. And 7 squared is 49. So this is a perfect square. Yeah. So what we could do is we could factorize this straight into the brackets. X plus whatever is a half of b, you put that in the brackets there, squared. Check how fast that was. But again, this is not for all quadratics. This is only for something that you could identify as a perfect square. So let me put it on next way. How do we know if something is a perfect square? If c is equal to a half of b squared, right? Or if c is equal to a half of b squared. So this is how we know if something is a quadratic. So let's go again. All right, let's go with y squared minus 2y plus 1. Good, so let's see. What is a half of b squared here? So a half, we can put it on the side, a half of minus 2 is minus 1, and minus 1 squared is 1. Yeah? So this comes, and that's this number that we have here. So it's 2y plus a half of minus 2 is minus 1 squared. Once we could identify that something is a perfect square, it could immediately go into y, and whatever half of b is, you put that inside the brackets there. That's how easy this is. Right? But again, only if you could identify that the quadratic is a perfect square. Right? Let's go with p squared minus 20p plus 100. Right? What is a half of minus 20? A half of minus 20 is minus 10. And you can do this in your mind, right? Or you can put it on the side. A half of minus 20 is minus 10. And then when you square that, what will you get? You get positive 100. And then that's this number here. So this is minus 10 squared, which is a half of minus 20. Yeah. What does it factorize into? It factorizes into p minus, well, p, and whatever is a half of b, that goes in the brackets, all squared. Yeah, that's how easy this is. It's so easy. If you know it is a perfect square, you don't have to go through the whole process of finding two numbers and multiply to give you 100 and when add giving you minus 20, right? But that's not the only way we're using it. We're using these in some little bit harder questions coming up, right? So x squared plus, let's go with 18x plus 81. Right? Let's see. Think about it in your mind. A half of 18 is 9, and 9 squared is 81. So this is a perfect square. right? 18x plus a half of 18 is 9 squared. So since this is a perfect square, we can factor it into x plus a half of 18 is 9 squared. Right? A good hint, what is a perfect square? Whatever is the sign in front of b, that is the sign that goes inside the brackets here. Right? Now, we're going to get a little bit more challenging now, right? Let's go with x squared plus 3x plus um, x squared plus 3x plus 9 over 4. Now, this one here is a little bit tricky. Is this a perfect square? So on the side, you find a half of 3. Now, a half of 3, we can write it as 3 over 2. 3 by 1 is 3 over 2. And what is 3 over 2 squared? This 3 over 2 squared means 3 over 2 by 3 over 2, which is 9 over 4. This is also a perfect square. So this becomes x squared plus 3x. This could be rewritten as 3 over 2 squared. So we know that this is a perfect square. So it becomes, when you factorize it, x plus a half of 3 is 3 over 2 squared. Now you could put 1.5, but my advice is for this section, learn to use improper fractions properly. Right? They will come in very, very handy, as we'll see in the upcoming videos, right? That's number 5. Number 6. Let's go again. Let's go with y squared minus 7y plus um 49 over 4. Let's take our time, right? What is a half of minus 7? A half of minus 7. I could rewrite this as minus 7 over 2. If you're not sure about how I got this, please ask me in the comment section. I will guide you to a video that shows you how to multiply a fraction by a whole number, right? And now when you square minus 7 over 2, what do you get? Minus 7 over 2 by minus 7 over 2 is 49 over 4, which is this number here. So this is a perfect square, right? Plus minus 7 over 2 all squared. And now what goes in the brackets is y, and whatever number is inside here, y minus 7 over 2 squared, or y minus a half of 7 squared. That's how easy this one is, right? So let's go with one more again. Last one. Let's go with p squared minus, let's go with 13. Let's go with 5 on 2p plus 25 on 4. Good. So so you take b, right? This is the process. You take b and you find a half of it. So a half of b is a half of minus 5 on 2, which will give me minus 5 on 4. And then you find minus 5 on 4 squared, which is minus 5 on 4 by minus 5 on 4, which is positive 25 on 4, which is this number here. So which means that this quadratic is also a perfect square, right? We could write it as p squared minus 5 on 2p plus this number here minus 5 over 4 squared. And now we could factorize this into p, and a half of minus 5 on 2 is minus 5 on 4 squared, right? So I give you more than enough examples here for you to go through this and figure out what is a perfect square, right? So as I said, everybody, I know it gets a little bit challenging, especially at this point. But at this point, you reach so far, so you don't have to give up. Don't give up at all, right? You all know a day fall in the comment section. You all could ask, and whenever I see the video and I see the comment, I'll try to help all you all, even if it means sending you all more videos, or links to other videos that I know that are good videos as well, right? So with that being said, this is the perfect square. And in the next section, we are going to learn how to use the perfect square to help us sketch a graph. Right? So that's it for this session. And until the next one, everyone, stay safe and I will see you on the next video.